Welcome to Science Decoded, where we explore the greatest mysteries of the universe through science. Today, we're following the incredible journey of a star, from a cold cloud of cosmic gas to one of the most powerful explosions in the universe. Let's uncover the complete life cycle of a star. Number 1. Where are stars born? Every star begins its life inside an enormous cloud of gas and dust, known as a stellar nebula. These nebulae stretch across hundreds of light years and contain mostly hydrogen, the simplest and most abundant element in the universe. Although they appear peaceful from a distance, gravity is constantly pulling the gas together. Over millions of years, dense regions begin collapsing under their own weight. Deep inside these cold cosmic clouds, the first stage of a new star quietly begins, hidden from the rest of the universe. Number 2. Gravity begins the birth. As gravity continues pulling gas inward, pressure and temperature at the center of the cloud begin rising dramatically. More and more material falls toward the growing core, making it hotter and denser with every passing year. Eventually, the collapsing cloud forms a bright object known as a protostar. At this stage, it isn't a true star yet because nuclear fusion has not begun. Even so, the young protostar shines brightly from the enormous heat generated by gravity alone. Number 3. A star finally ignites. When the core temperature reaches nearly 10 million degrees Celsius, something extraordinary happens. Hydrogen atoms begin fusing together to form helium, releasing enormous amounts of energy. This process, called nuclear fusion, marks the true birth of a star. The outward pressure created by fusion perfectly balances gravity pulling inward, creating a stable star that can shine for billions of years. From this moment forward, the star becomes a brilliant source of light and heat, illuminating surrounding planets and the darkness of space. Number 4. The main sequence. A star's longest life. Most stars spend about 90% of their lives in a stable phase called the main sequence. During this incredibly long period, hydrogen continues fusing into helium inside the core, producing a constant flow of energy. Our own sun has remained in this stage for approximately 4.6 billion years and is expected to continue for another 5 billion years. While stars may look unchanging from Earth, deep inside, powerful nuclear reactions are continuously shaping their long and remarkable lives. Number 5. When a star begins to die. No star shines forever. After billions of years, the hydrogen fuel inside its core begins to run out. Without enough hydrogen to sustain nuclear fusion, the balance between gravity and outward pressure starts to change. Gravity compresses the core while the outer layers expand dramatically. The star becomes brighter, cooler on the surface, and many times larger than before. This marks the beginning of the star's final evolutionary stages, a transformation that will completely reshape its appearance and determine its ultimate fate. Number 6. Red giant versus red supergiant. What happens next depends entirely on the star's mass. A medium-sized star, like our sun, expands into a red giant, becoming hundreds of times larger than before. Massive stars experience an even more dramatic transformation, becoming enormous red supergiants. Some of these giants grow so large that if placed where our sun is today, they could extend beyond the orbit of Mars, or even Jupiter. Their outer atmospheres become unstable as they approach one of the most spectacular endings in the universe. Number 7. The supernova explosion. For the most massive stars, the ending is unimaginably violent. Once nuclear fusion can no longer support the crushing force of gravity, the core collapses in a fraction of a second. Then, an enormous supernova explosion tears through the star, releasing more energy in moments than our sun will produce during its entire lifetime. The explosion blasts newly created elements across space, forming colorful, expanding nebulae that eventually become the birthplace of future stars and planetary systems. Number 8. White dwarfs, neutron stars, or black holes. A star's final destiny depends on how massive it was when it formed. Stars like our sun leave behind a small, incredibly dense white dwarf, which slowly cools for billions of years. More massive stars become neutron stars, where matter is compressed so tightly that a single teaspoon would weigh billions of tons. The most massive stars collapse even further, creating black holes, regions where gravity becomes so powerful that not even light can escape their immense pull. Number 9. Stars create the elements of life. Every atom of carbon in your body, every oxygen molecule you breathe, and even the iron flowing through your blood were forged inside ancient stars. During their lifetimes, stars create heavier elements through nuclear fusion. When massive stars explode as supernovae, these elements are scattered across space, enriching nearby gas clouds. Over billions of years, those enriched clouds form new stars, planets, and eventually life itself. In a very real sense, every living thing on Earth is connected to stars that died long before our solar system was born. Number 10. The future of our sun. Our sun is currently a stable main sequence star, about 4.6 billion years old. Scientists estimate it has enough hydrogen fuel to shine for another 5 billion years. Eventually, it will expand into a massive red giant, likely swallowing Mercury and Venus. Earth's fate remains uncertain, but even if our planet survives, its oceans will evaporate and its surface will become uninhabitable. After shedding its outer layers, the sun will leave behind a glowing white dwarf that slowly cools over billions of years. Thank you for watching Science Decoded. If you enjoyed exploring the incredible life cycle of stars, don't forget to like, subscribe, and turn on notifications. Which stage fascinated you the most? Let us know in the comments. Until next time, keep exploring and keep decoding science.